Ready. Hello, good evening. My name is Pradeep Raghu, and today we will be talking about the subject surveying as part of our RRB JE preparation. Okay. So today, first of all, we will start our discussion with respect to the syllabus of surveying for RRB JE, and after that we will try and take some questions covering each and every topic in our syllabus. As much as possible, we will try and discuss. Okay. So coming to the syllabus of this particular examination, you see it appears to be very big. Okay. So many statements are given, but the ones that I have highlighted here is the names of the chapters. So if you count it likewise, okay, it becomes more or less manageable for us. Okay. So the chapters that we have is chain survey, compass survey, followed by leveling, followed by contouring, right, followed by our plane table survey and the areas and volume calculations. So with chain survey, compass survey, leveling, and our Theodolite survey here, you can see here Theodolite survey. So with this particular 4 surveys, our 4 basic measurements are discussed: how to measure horizontal distance, how to measure horizontal angle, how to get vertical distance, and how to get vertical angles, right. The remaining chapters are plane table surveying, graphical method of surveying, calculation of areas and volumes is one of the most important objective of surveying, followed by we have tachyometry, small discussion on curves, only the types and setting out, followed by some advanced surveying equipment, aerial surveying, followed by remote sensing. So this is the syllabus. Don't get worried too much regarding the statements given, because they are just writing the contents in that particular chapters, which we are going to study. So a select number of topics are only there. Please remember, your RRB level is very fundamental. Only on the surface level we need to touch the concepts, right. Let us look at some questions here and try to understand. Okay, so please look at this. When the curvature of the earth is taken into account, the surveying is called as what, right? Geodetic surveying or plane surveying, preliminary survey or hydrographic surveying. So here, what is taken into account? Curvature. So if you are only considering the curvature of the earth, right, then the divisions of surveying are 2. What are they? Plane and geodetic surveying. So plane surveying means curvature of the earth is not considered. Geodetic surveying means curvature of the earth is considered. Okay, so this is one area that is important for us. What are the primary divisions of surveying? There are 2 primary divisions. First one is what we call it as the plane surveying. Second one is geodetic surveying. Okay, so what are the assumptions behind them? All these are very important for us. Okay, next step. Let us see the question here. So this is a question from scale. Which of the following statements in respect of map A having a scale of 1 in 1000 and another map B having a scale of 1 in 5000 is true? Map A is a largest scale map compared to map B. Map B is a large scale map compared to map A. Map B is a more detailed map compared to map A. None of the above. So here they are asking a question regarding the scale. So here the representation of the scales are in RF, correct now? Yes. Right, the representation of the scale are in RF. The 2 scales that we have is, first one is 1 in 1000. What is the meaning of 1 in 1000? Every 1 unit represents 1000 units on the ground. What is the second scale? 1 in 5000. What is the meaning? Every 1 unit in the paper represents 5000 units in the ground. Now if you observe here, okay, right, if the denominator of this particular RF, if this denominator of this particular RF is large, the entire fraction becomes small and this becomes a small scale. This becomes a small scale. Compared to this, right, this is the large scale and this becomes the small scale, because as the denominator of the RF is larger, the fraction becomes a small fraction and the scale will be called as a small scale. Okay, so who is a small scale here? Right, our map B is a small scale and map A is a large scale. So A is a large scale map compared to B. Okay, so there are 3 representations of scale, right, and here they are using the second representation known as the RF. First one is our engineer scale representation, where we will write 1 centimeter is equal to say some x meter, something like 50 meter, or 1 inch equal to 6 feet, or 1 mm is equal to 2 meter. That way of representation is known as engineer scale. We know that. This way of representation is our, a representative fraction. That's it. Next question, let us see. Right. So here we can see a scale representing either 3 units or only 1 unit, and its fractions up to second place of a decimal point is called as dash. You see, we have How many types of measuring scales? We have the following types of measuring scale. First one is what we call it as a plane scale. What does the plane scale will measure? Please remember, plane scale will only measure 2 dimensions. That is, it will measure 1 unit as well as 1/10th of the same unit. Okay. So it is only measuring 2 dimensions, unit plus its decimal point, 1 decimal point. Second one, what we have is called as a diagonal scale. Okay. So what happens with the diagonal scale is that you are going to have one particular unit, and we will measure 1/10th of the same unit, as well as we will measure 1/100th of the same unit. Okay. That means if I am designing a plane scale to measure in meter, it will measure in meter. And what is 1/10th of a meter? Decimeter. What is 1/100th of a meter? That is what we call it as centimeters. So if you are thinking about an example of a tape are graduated in meter, divided into decimeter and centimeters. So using a 20-meter tape, I can get the length as something like 12.85 meter and all. So you can see, right, 1 unit and up to 2 decimal places are there. So what is the answer? It has to be diagonal scale. The third scale that we have, type of scale that we have, is a chord scale. Chord scales are used to measure angles, we know that. Fourth one is what we call it as our vernier scale. Vernier scales are used to increase the accuracy of our main scale. And the final one what we have is called as a micro-optic scale. So micro-optic scales can give you finer values, right? It can give you better least counts compared to our vernier instruments. Okay. So as per this particular question, right, up to second place of its decimal point is what? A diagonal scale. Okay now? Yes. Next term, right? So you see, which of the following scale of the map is not affected due to shrinkage of map? So this is the point that I was trying to discuss in the previous question, the last two question. So the first type of representation is what we call it as the engineer's scale representation, right? Where I write 1 centimeter is equal to some x meter. The second representation of scale is what we call it as a representative fraction, where I'll write it as 1 in 1000, 1 in 5000 and all. And the third one is what we call it as our graphical scale. So what is our graphical scale? Okay. You see, graphical scale is a line drawn on the map or a plan, and it will represent a corresponding ground distance. So the point that I am trying to make is this. So imagine I am giving you a map like this. Now, if you are looking at our RF, and if you are looking at our let's say engineer scale, these are numerical values. For example, you see 1:5000 RF, another scale 1 centimeter is equal to 2 meter. These are all numerical scales. But what a graphical scale will be, right, he will look something like this. It will be a line drawn like this, and what they'll say is this is 0 meter and this is equal to say 100 meter. So what this particular scale tries to do is that they are trying to tell you that this much distance anywhere in your paper is going to represent what? 100 meters on the ground. So this particular scale is what we call it as the graphical scale. Now the advantage of this graphical scale is that, you see, if this map undergoes shrinkage after some 10-15 years, if this map undergoes shrinkage, once the shrinkage has happened, this RF is not valid, this engineer scale is not valid. The only scale that is valid is this graphical scale, because as the map shrinks, this graphical scale also shrinks with me. Therefore, the scale will be preserved. Example of where I use this is our Google Maps. So you can take your mobile phone, you can take your Google Map. At the bottom of the Google Map, this particular line will be drawn. That is known as your graphical scale. Right. So next time when you zoom in and zoom out, you can see the scale also changes. Why does it change? It is trying to make the adjustment so that the scale always remains a constant. So coming back to our question here, right, which of the following scale of the map is not affected due to shrinkage of map? The answer is graphical scale. Understand? Yes. So engineer scale, what is it? We understood. Representative fraction, what is it? We understand. Okay. Right. Next up. Plumb bob lines at 2 different places in geodetic surveying will be dash. So plumb bob means nothing but the direction of gravity. Plumb bob always represents what? Direction of gravity. So if my friend is here like this, and when he drops a plumb bob here, the plumb bob will show the direction of gravity. If I am having another friend here standing on the surface of the earth like this, if he drops a plumb bob, that plumb bob also will show the direction of gravity. And if a third friend is here, when he drops a plumb bob, this will be the direction of gravity. So what are they? They are always coming and acting like this. So let us see. They will intersect at the surface of the earth, intersect at the center of the earth, are parallel to each other, are perpendicular to each other. Which is the best possible answer? It is intersecting at the center of the earth. That is the best possible answer. Right, next up, you look at this. This is a very important principle of our chain surveying. Okay, let us read the question and discuss further. A well-conditioned triangle has angles not less than dash and not more than dash respectively. So, what is the principle of chain surveying? You see, the principle of chain surveying is what we call it as chain triangulation. I am writing in short letter, okay. What is the principle of chain surveying? It is nothing but chain triangulation. What do you mean by chain triangulation? It's very simple. Whatever area that we are having, that entire area has to be divided into network of triangles. But you are not allowed to divide divide the entire area into whatever triangle that you want. No, you have to divide all this area into something called as a well-conditioned, okay, I'll write in short letters, well-conditioned triangles. So when will you call a triangle as a well-conditioned? See, the idea is very simple. No angle in this particular triangle is too acute or no angle is too obtuse. And the limit of acuteness, generally we keep it as 30 degree, and the limit of obtuseness we generally keep it as 120 degree. So mathematically I can say like this: if you are having a triangle where all angles are lying in between this range, we call that as a well-conditioned triangle. Okay, na? Right? All triangles having angles lying in between these two extreme values, 30 and 120 degree end values, then I call that particular triangle as a well-conditioned triangle. Right? So you see, it should not be less than how much? 30 degree, and it should not be more than how much? 120 degree. So 30 and 120 degree should be the correct answers. None of these particular options are matching, so we can go for none of the above here. 30 and 120 degree is the correct answer. 20 is there, 120 is there. It's not really matching, so we can go for option D here. Yes. Right. Next, you see, which one of the following set of internal angles in degrees of a triangle does show well-conditioned triangle? So again, we are coming back to the same condition. It has to lie between 30 and 120 degree. Right. So any angle less than 30 you eliminate. Any angle more than 120 you can eliminate. So you see here, less than 20 is what? Less than 30, so we can eliminate. Okay. Right, next here 25, 45 is there, 25 is less than 30, so we can eliminate. Okay. Here 125 is there, more than 120, 15 is there, less than 30, so we can eliminate. So here you see, it is greater than 30, right, greater than 30 as well as greater than 30, right. So here we can take this answer as, right, option D. Right, that has to be the answer. Okay, right. Next, you see, this is another very important discussion from our chain surveying chapter. Offsets are what? See, what is the purpose of an offset? Once you take our baseline, right, like this, once you take the baseline like this, passing through the center of the area, right, we will count the distances along the chain, 0 meter, 1 meter, 2 meter, 3 meter, etc. So you imagine you are having a building here like this, and I want to find the position of that particular building. So what I'll do is, right, from this particular point, I'll try and put an, lateral measurement like this. What are these lateral sidewise measurements I'll take? We call them as offsets. Okay. So this is one terminology, please remember. For example, if this point is at 5 meter distance from the starting point, what is this 5 meter distance called as? It is called as chainage. What do you call this? Chainage. Chainage is the distance measured from the starting point along this particular chain up to the foot of this particular offset. We call it as what? Chainage. Right, and this offset is something like what? 12 meters. Another question that they can frame is this: what is the instrument that you use to measure offsets? The instrument that you use to measure offsets are tapes. Right, generally people say that tapes are used for linear measurements, horizontal distances and all, but the correct answer is tapes are used for measuring offsets. Please remember that. So here you see, this offset is exactly 90 degree to my chain line, so we call them as perpendicular offset. But what if I am having a building like this, right? If you are having a building like this, right? And if you're trying to plot this corner of the building by putting an offset like this, we call this particular offset as an oblique offset because it is not making 90 degree with the chain line. So this is known as an oblique offset. Since it is 90 degree, we will call it as a perpendicular offset. Similarly, based on length, we have short and we have long offsets. Remember, short offsets are less than 15 meters and long offsets are greater than 15 meters. But if you ask me, which one do I prefer to have in my field? Do I like shorter offsets or longer offsets? The answer is shorter offsets are always preferred. Okay, na? So here the best possible options I can select is perpendicular and oblique. Okay, right. Next up, you see, this is again another very important discussion, right? The discussions on the different types of chains. Okay, na? So please remember this, right? For all competitive examination, this is good. That dash is a 33 feet long and is mostly used for cadastral surveying. Okay, what is cadastral surveying? Right, cadastral surveying is also called as land surveying, where we are trying to establish legal boundaries and all. So the answer here is what? Revenue chain. Okay, so we have metric chains that comes in exact meter length. It will be either in 20 meter or either in 30 meter. 10 meter and all is also there, but mostly we use 20 meter and 30 meter metric chains. Okay, now next one is our revenue chain here. Revenue chain is exactly 33 feet long. It consists of 16 links. So if you do the mathematics, each link is equal to 1 by 16th of a feet. Each link is 1 by 16th of a feet. And if you convert this 33 feet into meter, it will be 10.06 meters. What is the value? 10.06 meters. The next chain is known as a Gunter's chain, also known as surveyor's chain. This particular chain is twice of this. This particular chain is twice of the revenue chain. So the length in feet is 66 feet. But please remember, he is having 100 link, means every link will be 0.66 feet. If you convert this into meter, it will be twice of that. It will be 20.12 meters long. That is our Gunter's chain. Steel band chains are not linked chains. These three are linked chains. Why we call it as linked chain? Because that 3-ring arrangement you can see here. That 3-ring arrangement you can see here like this. So that is a linked chain. But steel band chain is a continuous strip of steel. Okay, it comes in different length. Okay, generally in meters. Okay, so these are the different chain. One more chain that we have is our engineer's chain. So please study this. Okay, our engineer's chain is there, which is exactly equal to 100 feet up, and it is exactly equal to 100 links. So each link is equal to 1 feet. So again, if you do the conversion, the length of the chain in meter will be 30.48 meters. 30.48 meters. So these are the different types of chains. Please remember. Okay, right. Let us move on to the next question here. Right. So compensating errors in chaining are proportional to dash. Okay. So this is what their question is. So they are asking. You see, there are different sources of errors, but what is more important for us is the different types of errors. Okay. So coming to the type of errors, the first type of error is what we call it as a mistake. So what do you mean by mistake? Or rather, let us understand when does mistakes comes. Generally, mistakes comes when you are having confusion. Okay. So if you are not really clear what you are doing in the field, you are bound to make mistakes. Right. You might remember your teacher saying like this, please read the procedure and come to the lab. So when you are reading the procedure, what is that we are trying to eliminate? We are trying to eliminate our mistakes. Okay, because once you read the procedure, we are under the assumption that I will not make any mistakes in the field. Correct, na? So mistakes comes when you are having confusion in your mind, and this mistakes can be eliminated only if you read the literature. So it can eliminate. Okay, so read literature, you can eliminate mistakes. But the second type of error that we have is called as the systematic error. Okay, it's called as the systematic errors, or he is also known as the cumulative errors. Systematic or what? Cumulative errors. Now as the name indicates, these are always systematic. What do you mean by systematic? The meaning of systematic here is that it is always going to follow a given set of physical law, which will be always framed mathematically. Okay, for example, thermal expansion. The thermal expansion is a physical law, right? But we can frame a mathematical relation for it. For example, What is the change in length due to change in temperature? Change in length will be what? Alpha into delta T into L, right? So that is coefficient of thermal expansion, change in temperature and total length. So like this, so many errors are there. Error due to pull, error due to sag, right? So many errors are there. So as you can see, right, this particular change in length, that is the error that we are getting, is proportional to what? L. So what we understand? The cumulative errors are proportional to length. Okay, na? So please remember that. Cumulative errors and cumulative corrections for that matter will be proportional to the length of the lines. Now the third error that we have is what we call it as the compensating error. It's what we call it as compensating errors. Okay, and remember these compensating errors are proportional to what? They are proportional to square root of length of the lines. Okay, compensating errors are proportional to square root of length of the lines. Okay, so read the question carefully and try to understand what they are asking. In this case, they are asking you for cumulative errors. So let us see what the answer should be. Compensating errors, right? Compensating, oh here you see they are asking you for compensating errors. Compensating errors are proportional to what we discussed now, square root of length of the lines. Okay, so they are proportional to the length of the lines. No, this is true for what? For our cumulative errors. Proportional to the square root of the length of the line, that is correct. Understand? Proportional to the square root of length of the line. So here compensating is what they are asking. Be careful. It is proportional to the length of the lines. Square root of length of the lines. Okay, so how do we come to this and all is not really important. It comes from a chapter in mathematics known as theory of errors. For our RRB and all, such in-depth analysis is not required. Okay, it's a very easy examination. Okay, next step. Yes. On a rough terrain, what is the achievable accuracy of chain under, it's not conductive, it should be conducive conditions. Conducive conditions. Okay, so this is one tabulation that I want you to remember. So, right, I hope you understand this, what is meant by degree of accuracy. When we are doing our surveying in our fairly leveled ground, fairly flat grounds, and if you are using invar tape, right, and if you are using spring balance to measure the pull, if you are using thermometer to measure field temperature, then you can get a degree of accuracy of up to 1 in 10,000. 1 in 10,000, which is very good. What is the meaning of 1 in 10,000? In every 10,000 units you measure in the ground, you are going to get 1 unit of error. That is the idea. But if you are not using an invar chain, you are using an ordinary tested chain and all, and if you are not applying temperature correction or pull correction and all, then the degree of accuracy that you can get is only up to 1 in, right? Sorry, 1,000, not 10,000. You can only get this up to 1 in 1,000. Okay, like this. Right, now if the conditions are average, under average conditions, the degree of accuracy that will get is roughly close to 1 in 500. And remember this, generally asked question, in rough and hilly terrain, degree of accuracy is only 1 in 250. Okay, so this tabulation you should know. What is the degree of accuracy of chain surveying under different conditions? Okay, so here if you are having rough terrain, then the degree of accuracy should be what? 1 in 250. Do we have the option? Yes, I can select option B here. That's it. Okay, all right. So this is another important area for chain surveying. Let us look at the next question here. Yes. In the surveys, the slope corrections applied on the baseline is dash. So what is the slope correction? So there are different types of cumulative errors. I just mentioned in our previous question, right? For example, correction for temperature, right? Correction for pull. Another correction that we have is correction for what? Slope, right? Now please remember, what is the effect of slope? The effect of slope is always to increase the distances. Correct now? You are supposed to measure the horizontal distance between the 2 points, but if the ground is sloping like this, rather than getting this horizontal distance, you will get this sloping length. So who is greater? When the ground is sloping, this measured length is greater or the horizontal distance d is greater? Obviously, the measured length will be greater. Now what is the formula for the error? Error is calculated as measured value L minus correct value D. So as L is greater, L minus D will be positive. So the error is going to be always positive, and similarly correction is going to be what? Always negative. Let us see, what are they asking you? The slope correction Correction is what? Negative. Okay, let us look at the option. It is always cumulative, right? Yes. Always compensating? Not really. It is cumulative error only. Sometimes cumulative, sometimes compensating? Not really. None of this. The answer is it is always cumulative. What do you mean by cumulative here? It is following a certain rule here, right? Mathematically also we can write that rule. Length is going to be always more, right? This sloping length will be always more. And will it be cumulative? Yes, it will always be cumulative. It always keeps adding up to our measured value. Understand? Right. So what are the different types of cumulative errors? Please try and go through that. Just try to memorize this particular errors. That is more than sufficient. If you can remember the signs of the errors and correction also, it will be very, very nice. Okay now? Yes. Let us move on to our next discussion here. Look at this. Invar tapes are made of an alloy of dash. Invar is made up of an alloy called as nickel and steel. It's a combination of two. It's an alloy and it's a combination of two metals which are the nickel and steel. Nickel generally 36% and remaining 64% is what we provide as steel. Now what is the advantage of Invar? Please remember the coefficient of thermal expansion of Invar. Coefficient of thermal expansion of Invar is only 1/10 of coefficient of expansion of steel. Matlab, for if steel expands by 10 centimeter in a given temperature range, for that same temperature range, Invar will expand by only how much? Will only expand by 1 centimeter. Okay, right. So it's an alloy of what? Nickel and steel. Okay, that is the correct answer. Next step, please look at this. Right, when 2 points of surveying are mutually invisible, the following method of ranging is adopted. So basically we have the following three methods of ranging. First one is what we call it as direct ranging. First one is what I call it as direct ranging. Okay, so when will you call a ranging as direct ranging? I will go for a direct ranging only when the end stations are indivisible. That's very important. Matlab, I am standing here and I can see the opposite point of the survey line. That is what we call it as indivisibility. Now if this indivisibility is not there, we will go for something known as indirect ranging. We call it as indirect ranging, or also sometimes even call it as reciprocal ranging. Right, we also call it as what? Reciprocal ranging. Okay, right. So what is the field condition? The field condition is that I am standing at P, but the next end station is not visible for me. Right. For example, there is a small elevated ground in between, right, the two endpoints. You see, a small elevated ground is there in between these 2 points. Okay, this is P and Q. So you see, standing at this point P, can I see this point Q? The answer is no. So we cannot go for this, right, direct ranging. But if you want to do this particular reciprocal ranging, right, or indirect ranging, what should be there is that you should be able to identify a point in between P and Q from which you can see both the points. That is very important. Okay, if I stand at P, I cannot see the point Q, okay, but somewhere in between P and Q, you should have one point from which both of them are visible. Then only you can go for this, reciprocal ranging. Okay, so it is adopted for conditions such as hill. But what if there is no such intermediate point? What if such a point does not exist? Then reciprocal ranging is also eliminated. We'll go for the next method here, which is what I call it as the random line method, which is what we call it as random line method. So what is an example of this random line method? So imagine this. This is your ground that we are having. This is one ranging rod here. This is another ranging rod here, and you see this is a dense forest that we are having. Right. So you imagine that you are coming and standing here. Can you see the end stations P and Q? No, because you cannot see past a forest. Imagine you are going to come and stand here like this. Okay, you are coming and standing here inside the forest. Is this point visible? No. Is this point visible? No. So here, right, end stations are not visible. At the same time, there is no intermediate point from which I can see the end points. So what will I do here? I'll go for the third and final method of ranging. We call it as the random line method. So it is used for what? It is used for dense forest. Okay now? Yes. Right. So here the best possible answer that we can take is what? Indirect ranging. That's it. Okay now? Yes. Right. Let us look at the next question here. Okay. Yeah, so this is a question from our compass surveying, please read that. If the endpoints are free from local attraction, the difference between forebearing and backbearing of that line should be dash. So you see, this is a very important relation, right? What is the formula to calculate the backbearing of any line? Backbearing of any line is equal to forebearing of the same line plus or minus 180 degree. Please remember that. And when will you add 180 and when will you remove 180? Please remember, you can add 180 if the forebearing is less than 180 degree, and you can remove 180 if the forebearing is greater than 180 degree. Correct na? That is the logic. If you want to remove, if you want to remove 180 degree, minus 180 degree if you want to write, this angle should be more than 180 now, or else how will I remove it? That's the logic. So if your angle is more than 180, that forebearing, you remove it, 180 from it. If it is less than 180, right, what do? You cannot remove, minus 180 is not possible, so you add 180 to it. That's it. Just to remember like that. Okay. Now, what they are asking is, what is the difference between the forebearing and the backbearing of the line? What is the difference between them? Remember, this difference is always equal to 180 degree, provided there is no local attraction. Now, what if the difference is not equal to 180? In any case, if the difference is not equal to 180 degree, it means that you are having a local attraction there. So, let us go back. So, what is the answer? The difference between the forebearing and backbearing of a line that is free from local attraction is always equal to what? 180 degrees. That's it. Now, this is one small numerical model. You see, it's a higher level question for RRB, right? But let me just try and discuss this. So here they are saying if the magnetic bearing of the sun head known as 185 degrees and 20 minutes, the magnetic declination will be dash. The magnetic declination will be dash. So here the formula is declination is equal to, right, 180 degrees minus the magnetic bearing of sun at noon. That is the formula. Okay, na? Right, how that formula and all comes, you forget. Okay, so declination is equal to 180 minus magnetic bearing of the sun. So here it is 180 degree minus 185 degrees and 20 minutes, and you see you will get the answer as what? Minus 5 degrees and 20 minutes. Now minus declination means what? It is a western declination, so I can write like this: 5 degree 20 minutes west. 5 degree 20 minutes west has to be the answer, which is option C. Okay. Now, if this particular difference was positive, we will call that declination as what? Right, eastern declination. Here the declination is negative, na? So therefore you call it as what? Western declination. If this difference was positive, you can call it as what? Eastern declination. Okay, na? Right. Now what is declination? Please remember, if this is the direction of true meridian passing through a point, and if this is the direction of magnetic meridian passing through the point, the angle in between them is what we call it as declination. You see, this is true meridian, magnetic meridian is towards the east side, therefore we call it as what? Eastern declination. Therefore we call it as eastern declination. So it's a very simple numerical, that's why I have taken it. Right, if you want to try more questions on it, you can try, but not beyond this, okay? Right, don't go and try in-depth questions. That's not relevant for the RRB level examinations. Okay, now? Yes. Next up, please read this question. Yeah, so inclination of the compass needle to the horizontal towards the pole is called a dash. So it's the inclination of the needle. Okay, so what do you call this? You see, if I take a look at our magnetic compass here, let us see what the magnetic compass will look like. So you see, so inside the box of the compass, we will be having one central pivot like this, and this is the horizontal passing through the central pivot, and we expect our needle to be exactly horizontal. But sometimes what happens is the needle will make a vertical angle like this with the horizontal. This inclination or this vertical angle needle makes with the horizontal, that is what we call it as dip. What is that called as? Dip. So the needle is not horizontal. Unfortunately, the needle is inclined with the horizontal like this, either like this or it will be like this. So this vertical angle, this inclination is what we call it as dip. Okay, na? Now please remember, if you take the earth surface like this, along the equator dip angle is 0 and at the poles the dip angle will be what? 90 degrees. Right. So anywhere between equator and pole, dip will range from 0 to 90 degrees. So what is the answer here? The answer is what we call it as dip. Okay. Now what is declination? Right. Declination we already discussed now. Declination is the angle between the true meridian as well as the magnetic meridian. Now what do you mean by bearing? Right. Bearing is nothing but, you see, the angle a line makes with the reference meridian. So if this is a reference meridian here, and if you are having a line AB here, right, the angle between the meridian and the bearing is what we call it, the angle between the meridian and the line is what we call it as the bearing of the line, is what we call it as bearing of the line. If this is my true meridian, I call it as true bearing. If this is my magnetic meridian, I call it as magnetic bearing of the line. It's called as the magnetic bearing of the line. Okay, now, right. Now, can you tell me what is the angle between two lines called as? Right. What is the angle between two lines called as? Angle between lines are called as included angles. Angle between lines are called as included angles. Okay. Angle between line and meridian is called as bearing. That is the difference. Line and meridian is bearing. Right. Line and line is what we call it as included angle. That's it. Okay. Right. Now, azimuth is another name that we use for our true bearing. Okay. Azimuth is another name that we use for our true bearing, but it has to be in whole circle bearings. Right. That much and all is not required. Just remember, azimuth is another name I use for my true bearing only. Next step. Alright. So this is a small discussion here, very basic discussion. In compass surveying, if the whole circle bearing of the line is 237 degree 45 minutes, its quadrantal bearing is dash. So in whole circle bearing, what happens? In our whole circle bearings, what we will do is, we will always measure the angles from where? From the north end of the reference meridian, we will always measure in the clockwise direction. We will always measure in the clockwise direction. So if you are measuring in the clockwise direction like this, right, here will be 0 degree, here will be 90 degree, here will be 180 degree, and here you will be having what? 270 degrees. Matlab, in our WCB, the range of values of theta are from 0 to 360 degree. But in quadrantal bearings or in reduced bearings, what we do is, we will measure quadrant wise. We will measure only quadrant wise, like this. Okay. So if a line is lying like this is the reduced bearing of the line, and if this is theta, I will say it is measured in the northeast quadrant and the reduced bearing is north theta east. Okay, now if the line lies like this, right, this is the reduced bearing of the line, the acute angle of the line, and this is measured in the southeast quadrant, and if this is theta, I will call it as south theta east. If I am having a line like this, right, this is the reduced bearing of the line or the acute angle the line makes, and if this is theta, I will say it lies in the southwest quadrant, so south theta west. And finally, right, if this is where the line lies, this becomes your acute angle theta, and the reduced bearing of the line will be what? North theta w. Why? Because it is lying in the northwest quadrant. Right. Now let us look at this particular question here. What is the whole circle bearing? 237 degrees and 45 minutes. So 237 degrees and 45 minutes means what? Right, the line has to be here. It is in between 270 and 180 degree. So this is where my line lies. This angle is what they are saying as 237 degrees and 45 minutes. Right. So in the quadrantal bearings, where does it lie? It lies here south. It lies here, what is that? West. Okay, so it lies in the southwest quadrant. Look at this. How many options are we having where the line is lying in the southwest? How many options? So this is southeast, eliminated. This is also southeast, eliminated. This is also southeast, eliminated. The only one option where we are having southwest is option C. So any calculation is not required. If there was been one more option in southwest, then I will go for my calculation. Here I can use my logic and find the answer. Okay, na? Right. So such loopholes will be given in our question paper. So try to go for this elimination approach. It will be always easier. Once you identify the southwest quadrant, right, A, B and D are eliminated. Okay, right. Next step, right. So please look at this. So this is again a question from our plane table surveying, another important chapter for us, right? Yes, so I am getting some answers, very good. Okay, yes. Okay, right, next step. No problem, steel band chain never heard before, no problem, Messi. Yes, correct. Yes, okay, right, you are giving me the correct answers, very good. So, right, so this is one question from plane table surveying. You see, 2-point problem and 3-point problem are methods of dash. Tell me the answer, guys. Is it resection, orientation, traversing, or resection and orientation? Which is the best possible answer? Please remember, the best possible answer is resection and orientation. Because at the end of our 2-point and 3-point problem, what are we going to find out? We are going to find out the instrument station. Matlab, we will get our plane table oriented as well. So I am standing at one random point. I don't know where that point on the paper is, and I don't know whether the plane table is properly oriented or not. By the time you finish your 2-point or 3-point problem, the plane table also will get oriented. You will also get your instrument station. It will both happen together. So your plane table is oriented and you are finding the instrument station. Matlab, the best possible answer is resection and orientation. When will I go for traversing? I'll go for traversing if I want to find the boundary of a building, right? So if there is a closed boundary, something like this, then I'll try and do a closed traversing around this particular area. So to get a traverse from the wheel, I'll go for traversing. Orientation is a step that we have to do. It's a temporary adjustment that we have to do whenever there is more than one instrument station present. Okay, now? Resection is a method of plane tabling where we are trying to find out the instrument station. We have clearly discussed, right, the 4 different types of plane tabling methods and what conditions each is used. So here the best possible answer is option D. Next step, you see, similar question. 2-point and 3-point problems are methods of dash. Here what is the answer? Here the answer is nothing but resection. Here the best possible answer is resection. But in the previous question, resection is there, but resection and orientation is there. So the better answer is resection and orientation. That's the differences there. Okay, subtle points, small differences, but it makes or breaks our examination. Right. So when do I go for radiation? I'll go for radiation method if all points are indivisible and accessible from a single instrument station. When will I go for intersection method? I'll go for intersection method only when, right, the points to be surveyed or plotted are inaccessible. For example, there is a river flowing like this. I need to find the position of this point by keeping the plane table here. Okay, so I can see the points, but accessibility is not there. In that case, I'll go for intersection method. So as per this question, the best answer is resection. Okay, let us just move on. So you see, the type of surveying which requires least work in the office, right? So tell me, what is the survey that requires the least work in the office? It is plane table surveying. Okay, what is the answer? Plane table surveying. Why the answer is plane table surveying? Because it is the only graphical method of surveying. We don't carry a field book in our plane table surveying. Chain survey, compass survey and all, we carry field book. But in plane table surveying, there is no field book. Whatever drawing you are making on the paper, that itself is our end result. So there is no in between office work required. Right, that's it. Let us look at the next question. Please read this. This is from leveling. Please try to answer. Right. The method of leveling used to carry out reconnaissance of an area. Okay, so where do I go for reconnaissance? The answer for this question is nothing but option B. It is nothing but what? Fly leveling. Okay, right. It's very good. It's nothing but fly leveling. You see, fly leveling is adopted when the speed of the work is more important than accuracy. Speed is more important than accuracy. Example is your reconnaissance. I want to do my site visit as soon as possible and come back. We know in leveling work there are 3 staff readings now. Who are the staff readings? Back side, intermediate side and foresight. And remember, in case of this fly leveling, intermediate sides are not taken because I am not doing any detailing work. Backside, foresight and I will shift the instrument. Okay, check leveling I will do when I need to check the accuracy of the field work. I want to know whether the work you are doing in the field is correct or not, then only I go for this check leveling. Understand? Right. How do I do check leveling? That is not part of our discussion. Don't worry about it. Okay. When do I go for profile leveling? Profile leveling matlab, it is also called as, remember, longitudinal sectioning. Profile leveling is also called as longitudinal sectioning. So here what am I trying to do? I am trying to get the, center line profile of a civil engineering work. For example, a road is going like this or a canal is going like this. So what I will do is, along the center line of this canal, at regular intervals, I will try and find out the reduced levels. At regular intervals, I will try and find out the reduced level. So the center line profile I will get. Right. Together with this longitudinal sectioning, we also do cross sectioning like this so that we can find out the areas and volumes. Right. Estimate also we can find out. And the second one is, the last one here is simple leveling. I will go for simple leveling if I can find difference in elevations between the 2 points from a single instrument setup. Only one setup is required to find the difference in elevations between 2 points. I will go for simple leveling. That's it. Okay. Right. Next step. You see, crosshairs in surveying telescopes are fitted where? So if you remember, you see, this is how the objective of the telescope will look like, this is how the eyepiece will look like, and this is how the crosshairs are going to look like. Now tell me, is it kept exactly at the center? No, it's not at the center, it's not closer to the objective, but it is closer to what? To the eyepiece. Let us look at the options here. In the objective lens is wrong, at the center of the telescope is wrong, at the optical center of the eyepiece, in front of the eyepiece. Best answer is what? In front of the eyepiece. This is the optical center of eyepiece. This is the optical center of objective. There we cannot keep. Best possible answer is option D. Right. Very good. Shankar. Next step. Please look at this. A staff reading taken on a point whose elevation is to be determined as a change point. Elevation has to be written as a change point is called as what? Right. It is called as a foresight reading. Right. So foresight reading, right, it is also an intermediate sight reading. Alright. What is an intermediate sight reading? You see, intermediate sight readings are staff readings upon unknown elevations. Okay, staff readings upon unknown elevations. That is what we call it as the intermediate sight. When will be an intermediate sight becomes a foresight? If you are shifting the instrument after taking this. For example, the ground is something like this, right? And backside reading is the staff reading taken on the benchmark. So whenever you are looking and taking the reading on a benchmark, that is our backside. If you want to find the elevation of this point C, I will call it as intermediate sight. But after taking the reading on this point E, if you are changing this instrument from here to here, then point E is called as a change point. This reading will be what? Foresight. After shifting, you will know the elevation of this point. Let me say it is now 99 meter. You calculate it. Then this reading after shifting will be called as what? Backside, because this is a point of non-elevation for us. Okay, so these are the different types of staff reading: backside, intermediate side and foresight. As per this question, the answer is option A. Correct now? Yes. Right, very good, Catherine. Okay. Next step. Right, you see, right, for true differences in elevations between 2 points A and B, level must be kept where? So this is my question. Can anybody give me the answer? Right, these are 2 points and I want to find out the true difference in elevations between the points. Even if the instrument is having errors, I want to find the true difference in elevations. Then where will I keep the instrument? Exactly midway between the staff station. Can anybody please tell me, right, what is this particular methodology called as? Right, I should keep it exactly in between the two staff station. Can anybody tell me? Anil, Catherine, Shankar, Mahanadi, can anybody tell me what do you call this concept as? Come on, anybody? Right, so this is what we call it as, please remember, balancing of sight. This is what we call it as, balancing of sight, okay. Okay, so if you keep the, yeah, very good, yes, that's it. So at any point in between A and B, at the exact midpoint of A and B, near the point A, near the point B, the best answer is B. Very good. Okay, balancing, very good. Janardana, very good, the answer is correct. Yes. Let us look at this question here. Okay, the line normal to the plumb line is known as, the line normal to the plumb line, okay. So plumb line is the direction of gravity, normal to that is what, right, it is horizontal line. Yes, horizontal line is there, but you see, right, level line will also come like this, right. So here, who should be the best possible answer, right? Let me just draw it, okay. So imagine you are having a ground like this. This is a point A. Tell me, right, what is a level surface? A level surface is a curved surface like this, parallel to the mean spheroid of the earth. What is this? This is the level surface. What is a horizontal surface? Horizontal surface is tangential to this particular level surface. What is vertical surface? It is normal to this particular, horizontal surface. And the example of this vertical surface or vertical line is nothing but our plumb line. That means the line shown by the plumb. So here, what should be my answer? Should it be horizontal line or it should be vertical line? The answer should be what? Vertical line. Because you see, right, if you are selecting the answer as horizontal line here, it means that, right, all along the horizontal line, direction of gravity like this, direction of gravity like this, direction of gravity perpendicular, direction of gravity perpendicular, direction of gravity perpendicular. So here also, direction of gravity perpendicular, 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 perpendicular like this. Now tell me, is this how the direction of gravities are? Do you think they are always parallel to each other? No, no. They are what? They are converging to the center of the earth. So the correct answer here should be what? Level surface only. Understand? Right, because at any point if you want to know the direction of gravity, first of all you will take the level surface passing through it, next you take the horizontal surface tangential to it, then you make the vertical surface perpendicular to it. Now you see everything is going to converge at the center of the earth. So it's a very good question conceptually. The best answer that you can take is level line or level surface. Okay na? Yes. Right, it's level line or level surface. Very good. Okay. Yeah, that's it. Next question you see, right? An internal focusing type surveying telescope may be focused by the movement of what? May be focused by the movement of what? So you see, in the internal focusing telescope, we will be having an extra additional focusing lens. Correct na? Right, extra additional focusing lens will be there. That is a double concave lens. Right, this is convex and this is concave. And if you remember, we have discussed that we should move this lens by rotating the focusing screw here. So what is that? That is a double concave lens that we have. Planar convex lens is used in our Ramsden's eyepiece, that we don't want. Concave lens, convex lens, objective lens, the answer is concave lens. Double concave lens in our telescope. Understand? Right, that's it. Okay, so are you able to answer it? Very good. Right, that is that. So Shiva, very good Shiva, very good. Okay, next look at this. Okay, which of the following instruments is used for centering the theodolite in windy conditions? Right, you see, generally for centering, the instrument that we use is nothing but the plumb bob like this. If the plumb bob is not there, you will take a stone and you will drop like this. But please remember, both of this will not work if there is too much wind. If there is too much wind, we will take the help of a laser pointer like this. We take the help of a laser pointer. So like this, you see, this is a laser pointer. So at the bottom of the instrument, this laser pointer will be there and it will be hitting the surface like this. So like this, it will try and show. This is what we call it as the optical plummet. So the advantage is, even if wind is there, no problem is there. Right. So do we have the answer? Yes. Optical plummet. Cross staff is used for setting out offsets. Cross staff is used for setting out offset. Optical square is also for setting out offset. Spirit level is done for leveling. Then the only possible answer is what? Optical plummet. So if you don't know optical plummet, go for elimination approach. That's it. Okay, right. And let us look at the next question here. Okay, so you see the least count of a theodolite, right? Standard value, it is 20 seconds. Right, least count of a vernier theodolite is what? 20 seconds, please remember. What is the least count of the leveling staff? Least count of leveling staff is what? 5 mm or 0.05 meters. Okay, these are standard values. I know that you know this. Very good. Next question, let us see. Right, so another question from theodolite. While using a theodolite, how to change the reading on the horizontal circle while measuring a horizontal angle? This also we discussed, correct na? So how many clamps we have? We have 2 clamps. Who are they? Upper clamp and lower clamp. Remember, if the upper is tighter, lower is tighter, what will happen? No rotation, no rotation, no rotation. Okay na? Yes. Now tell me, if the upper is tighter, and if the lower is loose, what will happen? There is no rotation will be there, rotation will be there, but no change in reading will be there. No change in reading. Rotation will be there, but no change in reading will be there. Sorry, no change in reading will be there. Rotation will be there without change in reading. The last combination is the upper clamp, the vernier is loose, right? Upper clamp loose means vernier is loose, but lower is tight. That means the main scale is tight. So the main scale is tight, but the vernier is free to move. So what happens? We will get rotation with the change in reading. With the change in reading. So what is the combination? The upper is loose, lower is tight. Let us look at this. Both upper and lower are loose. No. Upper clamp is loose, lower clamp is tight. Yes. That's it. Both are tightened. No. Upper clamp tight, lower is loose means rotation without change in reading. So they are asking how to change the reading on the horizontal circle. The answer should be B only. Okay now? Yes. Right. Now let us look at this particular question here. Yeah. So it's not D actually, it is B. Okay. Right. Nikita. Right. Janardana also slightly got it wrong. It's not D. Okay. It's not D. It's B. Change with the change in reading they are asking. Okay. Right. Next, in a closed traverse, right, difference between forebearing and back bearing should be 90. No, difference between forebearing and back bearing is what? It is should be equal to 180 degree if there is no local attraction. Sum of included angles should be 2n minus 4 times the right angle, where n represents the number of sides. 2n minus 4 is for what? Interior angles. For interior angles, that is correct. Yes. Sum of included angle should be 2n minus 1. There is nothing like that. 2n minus 1 formula is not there. None of this. So here the best possible answer is B. The best possible answer is B. Right. Now this is for interior angles. What is the sum of exterior angles? Right. What is the sum of exterior angles? It should be what? 2n plus 4 into 90 degrees. 2n plus 4 into 90 degrees, where n represents the number of sides. Okay now? Right. That's it. Now one last question we will see here is this. So you see, which of the following methods of contouring is most suitable for hilly terrain? Tell me. There are different methods of contouring. We are having our, you see, our plane table method. We are having tachyometric method, method of grid, method of cross section. Tell me, where do I use, what do I use in hilly terrain? In hilly terrain, the best possible answer is what? Tachyometric surveying. Okay na? In hilly terrain, the best possible answer is what? Tachyometric surveying. Very good, Janardana. Right. Because you remember the formula for distance is what? K into S plus C for our tachyometer. What is K? Multiplying constant. What is C? Additive constant. Now generally, right, what we need to do is just to take the staff reading from the field. Keep your tachyometer here, keep your staff there, take a staff reading, right, then you will get the S value. Now generally, what is the value of K? Come on, tell me. What is the value of K? Come on. Very good. The value of K is nothing but 100. The value of C is generally equal to 0 under analectic condition. Right. So generally, this is what we will take under analectic conditions. Yes, very good. Shankar, yes. So now, if the staff reading is something like say 2 meter, what is my horizontal distance D? It becomes what? 100 into 2, it is directly what? 200 meters. So now I have distances and I can easily find out the reduced levels from the staff readings. So I can do my contouring work very easily. That's it. So these are some questions from our that are worth trying in our RRB JE. Numericals and all not that much important. Don't go in depth. If at all, if you are going through numericals, formulas of the numericals will be more important because they will ask you to identify certain formulas. Okay. Thanks a lot. All the best. I hope you are able to answer all the questions, right? If you are having any doubt, you can feel free to contact. Thanks a lot. All the best. God bless you. Thank you.